China's J-35 fighter jet, the rising dragon of fifth-generation warfare. In the evolving landscape of military aviation, a new contender has emerged from the east. The Shenyang J-35, China's latest achievement in fighter jet technology, represents Beijing's ambitious push to modernize its air force and challenge Western dominance in the skies. Today, we dive deep into this remarkable aircraft, exploring its capabilities, technologies, and what it means for the balance of power in 21st century aerial warfare. To understand the significance of the J-35, we must first look at China's journey in military aviation. For decades, China's People's Liberation Army Air Force relied heavily on modified Soviet designs and reverse-engineered technology. The nation's aerospace industry was considered generations behind Western powers. This began to change in the early 2000s with China's economic rise and increased military budget. The development of the J-20, China's first fifth-generation fighter, marked a turning point. But it was the FC-31 prototype, first revealed in 2012, that would eventually evolve into the J-35 we see today. The J-35 emerged from the Shenyang Aircraft Corporation's FC-31 demonstrator, refined through years of testing and technological advancement. Unlike its predecessor, the J-20, which was designed primarily as a high-altitude interceptor, the J-35 was conceived as a more versatile multi-role fighter, China's answer to the American F-35 Lightning II. The J-35, also sometimes referred to as the J-31 or FC-31 during its earlier development stages, is a twin-gen midweight stealth fighter developed by China. Measuring approximately 17.3 meters in length, with a wingspan of around 11.5 meters and a height of 4.8 meters, the aircraft has an estimated empty weight of 17,000 kg and a maximum takeoff weight of about 28,000 kg. It is powered by twin WS-13E or the more advanced WS-19 turbofan engines, allowing it to reach speeds up to Mach 1.8. Roughly 2,200 km/h. The fighter boasts a combat radius of approximately 1,200 km and a service ceiling estimated at 18,000 meters. The J-35's design emphasizes stealth and versatility, featuring radar-defeating characteristics such as carefully aligned edges, canted vertical stabilizers, and internal weapons bays. Its twin-gen setup not only provides redundancy in case of engine failure, but also offers a potentially higher thrust-to-weight ratio, improving maneuverability and performance, especially at high altitudes. At the heart of any fifth-generation fighter is its stealth technology, and the J-35 is no exception. The aircraft employs a comprehensive approach to reducing its radar cross-section. The J-35's stealth characteristics begin with its shape. The aircraft features a diamond-like wing design, chimed nose section, and carefully aligned edges that scatter incoming radar waves in predictable directions away from their source. This dramatically reduces the aircraft's visibility on enemy radar systems. Complementing these geometric features is the application of radar-absorbing materials, or RAM. These specialized coatings and composites further reduce radar reflectivity by absorbing electromagnetic energy. The J-35 also employs careful infrared signature management. Its engine nozzles are designed to minimize heat signatures, making the aircraft difficult to detect by heat-seeking missiles and infrared search and track systems. Chinese engineers have particularly focused on frontal aspect stealth, optimizing the aircraft to remain undetected when approaching enemy air defenses, a critical capability for penetrating heavily defended airspace. Modern air combat is as much about information superiority as it is about kinetic performance. The J-35's sensor and avionics package represents the cutting edge of Chinese military technology. At the heart of the J-35's sensor suite is its Active Electronically Scanned Array, AESA, radar, believed to be the KLJ-7A, developed by the Nanjing Research Institute of Electronics Technology. Unlike older mechanically scanned radars, this AESA system can track multiple targets simultaneously with greater precision and resistance to jamming. The radar is complemented by an electro-optical targeting system, EOTS. giving pilots the ability to identify and engage targets passively without emitting detectable radar signals. This system combines infrared search and track capabilities with a targeting pod functionality. Information from these various sensors is fused into a comprehensive tactical picture displayed on large multifunction screens in the cockpit. Chinese sources claim this integrated approach provides pilots with unprecedented situational awareness. The J-35 is reportedly equipped with a distributed aperture system similar to that found on the F-35. This network of infrared sensors mounted around the aircraft provides pilots with a 360-degree view of their surroundings, displayed directly on their helmet mount displays. Modern warfare depends on connectivity, and the J-35 represents China's vision for networked combat operations. The fighter is equipped with advanced secure data links, allowing it to share tactical information with other aircraft, ground control stations, and naval vessels. This network-centric capability enables what Chinese military theorists call system of systems warfare, where the effectiveness of individual platforms is multiplied through integration. A key component is the aircraft's artificial intelligence-assisted data fusion system. This technology filters and prioritizes the massive amount of information available to the pilot, presenting only what's most relevant to the current mission phase and threat environment. Unlike earlier Chinese fighters that operated with minimal connectivity, the J-35 can function as both a sensor node and a shooter within China's integrated air defense network, potentially coordinating with unmanned systems and other manned aircraft. The J-35's offensive capabilities are built around versatility and stealth preservation. To maintain its low radar cross-section, the aircraft carries its primary weapons in internal bays. The main weapons bay can reportedly accommodate up to 4 medium-range air-to-air missiles, such as the PL-15, which is comparable to the American AIM-120 AMRAAM, with a reported range exceeding 100 kilometers. For closer engagements, the J-35 can deploy the PL-10 short-range missile with high off-bore sight targeting capability. For air-to-ground missions, the J-35 can carry precision-guided munitions, including the wide J-91 anti-radiation missile for suppression of enemy air defenses and various laser and satellite-guided bombs. When stealth is not a priority, additional weapons can be mounted on external hardpoints, significantly increasing the aircraft's ordnance capacity at the cost of increased radar visibility. Chinese military publications suggest the J-35 may also be capable of carrying hypersonic missiles in the future, potentially giving it a standoff attack capability against heavily defended targets. Given its similar role and appearance, comparisons between the J-35 and America's F-35 Lightning II are inevitable. Let's examine how these two fifth-generation fighters match up. Physically, the J-35 and F-35 share several characteristics. Both are single-seat, stealth-optimized multi-role fighters. However, the J-35's twin-section configuration represents a significant departure from the F-35's single-engine design. This twin-engine approach potentially offers the J-35 advantages in thrust-to-weight ratio and engine redundancy. However, it comes at the cost of increased complexity, maintenance requirements, and potentially larger radar cross-section due to the need for 2 engine inlets and exhaust nozzles. In terms of avionics, the F-35 maintains an edge with its mature sensor fusion technology and the combat-proven distributed aperture system. The F-35 benefits from decades of American experience in stealth technology and sensor integration. However, Chinese analysts claim the J-35 offers superior kinematic performance, essentially better maneuverability and acceleration, compared to the F-35, particularly the F-35A variant. This could potentially give it an advantage in within-visual range dogfighting scenarios. The F-35's greatest advantage may lie in its proven operational status and the extensive multinational ecosystem supporting it. The aircraft has accumulated thousands of flight hours across multiple air forces, while the J-35 remains relatively untested in operational conditions. Cost represents another significant differential. While exact figures remain classified, experts estimate the J-35 may cost between $70 to $85 million per unit, compared to the F-35A's approximately $80 to $100 million price tag. This cost advantage could make the J-35 an attractive option for nations looking to acquire fifth-generation capabilities at a lower price point. The J-35 represents not just a military asset, but a potential export success for China's growing defense industry. Production of the J-35 is centered at Shenyang Aircraft Corporation's facilities in northeastern China. Chinese state media has indicated plans for large-scale production to equip both the People's Liberation Army Air Force and the People's Liberation Army Navy. The naval variant, sometimes designated as the J-35A, features strengthened landing gear, a tailhook, and corrosion-resistant materials to withstand the harsh maritime environment. This variant is being developed for deployment on China's growing fleet of aircraft carriers, including the new Type 003 Fujian with its electromagnetic catapult system. On the export front, the J-35 represents China's first truly competitive offering in the high-end fighter market. Unlike the larger J-20, which China has shown little interest in exporting, the J-35 has been actively marketed to international customers as the FC-31. Potential customers include traditional Chinese defense partners like Pakistan, as well as nations that seek fifth-generation capabilities but face political or financial barriers to acquiring Western aircraft. The aircraft's relatively lower cost compared to the F-35 makes it particularly attractive to middle-income countries with modernization ambitions. The J-35's introduction signals China's evolving approach to aerial warfare and power projection. In Chinese military doctrine, the J-35 serves multiple roles. First, it provides a stealthy penetration capability against sophisticated integrated air defense systems that have proliferated across the region. Second, when deployed on aircraft carriers, it extends China's ability to project power beyond the first island chain of the series of archipelagos that runs from Japan through Taiwan and the Philippines, historically constraining Chinese naval operations. In a theoretical conflict scenario, J-35S would likely operate in concert with other Chinese assets. Initial strikes by ballistic and cruise missiles might target enemy airfields and air defense nodes, creating gaps for J-35S to exploit. These fighters could then penetrate enemy airspace to attack high-value targets or establish air superiority for follow-on operations by less stealthy aircraft. Chinese military theorists have emphasized the J-35's potential role in what they term system destruction warfare, the targeted neutralization of an adversary's command, control, and information systems to paralyze their military operations. Despite its impressive capabilities, the J-35 faces significant challenges and limitations. Perhaps the most critical challenge lies in propulsion. China has historically struggled with indigenous jet engine development. Early prototypes of the FC-31 relied on Russian RD-93 engines, while production J-35S are expected to use the domestic WS-13E or eventually the more advanced WS-19. These Chinese engines may still lag behind Western counterparts in terms of thrust, fuel efficiency, and reliability, potentially limiting the aircraft's performance and operational readiness. Questions also remain about the maturity of Chinese stealth technology. While the J-35's shape incorporates radar-defeating features, effective stealth requires precision manufacturing and specialized materials that China is still mastering. The sophistication of the J-35's avionics and sensor fusion capabilities also remains somewhat unclear. Western analysts note that China has made rapid advances in these areas, but may still be working to close the gap with the most advanced American and European systems. Finally, there's the human element. The effectiveness of any fighter aircraft depends not just on its technical specifications, but on pilot training, tactical doctrine, and combat experience, areas where Western air forces still maintain significant advantages. The emergence of the J-35 has significant implications for the strategic balance in the Indo-Pacific region and beyond. For neighboring countries with territorial disputes with China, such as those in the South China Sea, the J-35 represents a concerning advancement in Chinese air power projection capabilities. It potentially threatens to overcome existing defensive systems and alter regional security calculations, For the United States and its allies, the J-35 represents another data point in China's accelerating military modernization. It challenges long-held assumptions about Western technological superiority and complicates defense planning. The export potential of the J-35 adds another dimension, as China offers fifth-generation capabilities to countries that might otherwise be unable to acquire them. New dynamics emerge in regional power balances from Southeast Asia to the Middle East and Africa. Military analysts also note that the J-35 program has generated valuable experience for China's aerospace sector, accelerating the development of technologies that will benefit future aircraft designs and other military systems. Looking ahead, the J-35 program is likely to evolve significantly over the coming decades. Chinese aerospace publications have hinted at several planned upgrades, including more powerful indigenous engines, advanced electronic warfare capabilities, and integration with unmanned combat aerial vehicles. One particularly interesting concept involves using the J-35 as a loyal wingman controller, directing multiple unmanned combat aircraft in high-risk environments, a concept similar to the U.S. Air Force's Collaborative Combat Aircraft program. My Chinese researchers are also exploring integrating artificial intelligence more deeply into the aircraft systems, potentially enhancing pilot decision-making or enabling more autonomous operations in communications-denied environments. Naval applications remain a priority, with continuing refinements to the carrier-based variant to optimize it for operations from China's expanding carrier fleet. The Shenyang J-35 represents much more than just another fighter in China's growing arsenal. It symbolizes China's ambition to transform from a regional military power to a global one, able to design and produce the most sophisticated weapon systems in the world. While questions remain about certain aspects of its performance and capabilities, the aircraft undeniably narrows the technological gap between China and traditional military powers. It offers China new options for power projection and territorial defense, while potentially reshaping the export market for advanced combat aircraft. For military planners across the Indo-Pacific and beyond, the J-35 demands attention and respect. It signals that future conflicts may be fought between adversaries with increasingly comparable technological capabilities, a dramatic shift from the asymmetric advantages Western forces have enjoyed for decades. As this remarkable aircraft continues its journey from prototype to operational deployment, its impact on regional security and the global balance of power will only grow. The Dragon has taken flight, and the world's skies will never be the same. So, could China's J-35 be the game changer in fifth-generation warfare, or is it still playing catch-up with American giants like the F-35? Will this stealth jet shift the balance of air power in the Pacific? Let us know your thoughts in the comments below, and if you enjoyed this breakdown, don't forget to like the video and subscribe for more high-stakes military tech analysis. See you in the next mission.